So here we have another example where we're taking the derivative. Remember, instead of f prime of x, if our function is given as f, we can also write it as df dx. And this time the equation is 2x squared minus x. Again, maybe hard to read on my screen, but I'm using the definition of derivative. So first, I need to find the simplified difference quotient. And if you remember, we start by taking the whole equation and writing that first. So 2x squared minus x, where for the input, I need to, in this case, use x plus h. And notice both of these have x plus h. After the first example, that sometimes throws people off because they feel the minus piece should just have an x. But remember, I'm doing the top left piece where all of the x's, and in this case, because there were 2 in the equation, are both replaced with x plus h. Now I subtract the equation 2x squared plus 2x squared minus x, and on the second time, we just put x's. So hopefully you can see the parallels now. And again, this is all over h. I've got my initial filled in difference quotient, and I'm ready to start cleaning it up algebraically. So let's see, I've got 2 times the x squared plus h quantity term squared, which is what we had last time. So I need to expand that into the first squared plus the last squared plus 2 times the first times the last. Then I'm ready to distribute that minus sign to the rest of this top left term, minus x minus h. And now I'm ready to move on to the top right of the equation, again distributing a minus sign for minus 2x squared plus x, right? Because I have a minus times a minus to give me a positive x. And again, it's all over h. Now last time after the initial distribution we were done, but we have a 2 that still has not been distributed. So we're going to distribute that 2. And don't forget that that middle term is going to turn into a 4 because of 2 times 2. And now I can just copy the rest of the equation. Once we have distributed everything in the numerator and we're ready to cancel like terms, remember the entire top right of the equation should be able to cancel. If not, somewhere we've made a mistake in our calculations. So my 2x squareds have a positive and a negative that will add to 0. My negative x and my positive x will add to 0. And yes, everything on the right side is going to be canceling. And I am left with the 4xh plus 2h squared minus h all over h. Just like last time, we need to factor the h out. Be careful. You started with a trinomial, so once you factor, you should still have a trinomial. A lot of people miss this minus 1 on the end, but if I distribute it back, h times minus h gives me the minus h from the original equation. And now I can cancel h's, and so I'm left with 4x plus 2h minus 1, and this is the simplified difference quotient that's ready to have the limit taken of this. And so now we can take the derivative, really I should have said the limit, of the simplified difference quotient. So we have our f of x equals the limit of the 4x plus 2h minus 1. So remember the way we do this is we're going to get rid of the limit and all the h terms at the same time. So the limit as h goes to 0 goes away. At the same time, the h terms go away, and we've got f prime of x equals 4x minus 1. Don't actually cross all of those off because otherwise the line above is technically wrong, but we've got our answer. You're done. The derivative of the original equation 2x squared minus x is 4x minus 1, and this is the slope of all of the tangent lines to the original equation.